Alright, hello and welcome to my 2D Left 4 Dead in Unity tutorial thing. Today we're going to be covering basic pathfinding, essentially. So you'll see that we've got a little level drawn up here. The red bits indicate where these are basically unwalkable nodes, the edge of the level and so forth, and whatever. And the blue bits are bits you can walk on. And if I just press play here, you'll see that that little one there will follow a path to a random point and avoid the red ones while only using the blue ones and such, and when they get to the end of the path they will choose another point to go to. And yeah, you get the idea. Okay. So, as odd as it may seem, I'm actually going to point you to another tutorial that'll explain how A-Star works and how to implement it a lot better than I can do. And I've already tried it before in some of my older tutorials. So I think it was like in the what was it? I think in the what was it? RTS tutorial, I've done an implementation of A-Star where I explained it, or I might have just copped out again, but yeah. So there'll be a link to Sebastian Luke, I'm not sure how to pronounce it, I'm sorry, but he does an excellent tutorial on the A-Star pathfinding and implementing it in Unity. So he's got like an algorithm, node grid, and implementing it, and I'm not sure what heap optimization is, but that's there. And then he's got stuff like weights, if you want to alter the weights of pathfinding, so say roads were more desirable than just walking along grass or something. And then he's got smoothing, so it doesn't look completely artificial, like you're just moving in right angles and stuff. And then threading for dumping it all to a separate thread for increased performance. So yeah, so that link will be in the description. I will hover over the actual code, just so if you're following along and copying, then you can watch that. Sorry, you can just pause it and then read and write it yourself and understand and whatever. The main bit of my focus will be actually generating the grid, because I do that from tile map that I did it for the RPG tutorial where we generated A-Star nodes from tile maps, but I've changed it slightly so it works a lot better. So that's mainly what I'll be going over today. Okay, so let's get to it. Okay, so first off, we have our the script to create the pathfinding nodes. So if I just actually click play and pause it quickly, you'll see that we've got a load of white squares here, which represent each of the pathfinding nodes. And if you click on them, you'll see we get things like the neighbors to the node, the position in the world, its costs, which are just to do with actually finding a path, the grid X and Y coordinates for where it is in the 2D array that is sort of representing the world, you get my meaning, and the modifier it has, and stuff like that, and whether it's walkable or not. So if we click here, we'll see that this node isn't walkable because it's in the red, whereas this one is walkable because it's in the blue. Okay, now let's get onto it. So we'll just see a couple of variables here. We've got a prefab, a game object prefab, which is just for the node. So that is basically just a sprite renderer with a little blob to show us where the node is, and our path node script, which is basically just an A-Star node, so with the name set to path node. Okay, go back to that. Next up, the one layer you'll need is the floor, which basically represents everywhere where a tile should be, basically. So if there is a tile on that layer in a position, then if it's within these coordinates set for creating nodes, so you'll see there's a starting X, starting Y, finish X, finish Y. So if there is a tile on the floor tile map there, then it will create a pathfinding tile. And likewise, whether this node is walkable or not, is defined by the obstacle layers. So once we've got the floor, we'll check all the obstacle layers for if there's also a tile there in those layers at the same location. And if there is, we know, all right, there's an obstacle there, we'll set it to unwalkable. Likewise, starting X, starting Y, finish X, finish Y. These are basically coordinates. Well, coordinates, sorry. So this is basically just the area we search for tiles in the floor tile map to create nodes for. So it just creates a big square like that. Not to scale, but you get the idea. Now let's get on to the code. So yeah. We've also got another list of game objects called the unsorted nodes. These are basically just where we dump the words failing. This is where we put the nodes before we put them in a 2D array in order. And likewise, the public path node, nodes in world, is a 2D array of where the nodes will be. So it's a 2D array of nodes relative to where they are in the world. So the neighbours in the array will be reflective of the neighbours in the world, if you get what I mean. So yeah. So on awake, we just set the singleton to be this, and likewise we call the create nodes method. So we've got two variables here, just integers. These are the grid X and grid Y. These are basically just going to be the coordinates in the array. So when we're going through all these tiles, we use these to just like keep track of when we found a tile, we'll increment them, and we'll be able to use this as the index for the 2D array once we get around to populating it. I've also got a boolean for found tile. So this basically just says whether we found a tile on the last pass. It's mainly used for, what was it? Well, the only use of it is for whether we've actually found a floor tile in the first place, because if we didn't have that, you could technically do away with it, but you'd have to have like a 100 by or 200 by 200 array, and that would be a bit inefficient because most of them would be null, because as you can see, our level is not 200 by 200. So by just having a quick check for found tile, it lets us work out where the actual array starts, and we can have it in the smallest size possible. Okay. So now we've got onto two nested for loops. So basically we go through for int x equals starting x to finish x, x plus plus, for y starting y, and y plus plus, you know. We create a vector-free int of position just from x, y, and 0. And then on floor, we try and get a tile from this position that we've generated from the x and y. So if the tile is null, then, so if we've not found the floor tile, but if we have found a tile previously, so we would be somewhere within the level, then we are going to increment the grid y, because even though we've not found a tile, we're going to continue like incrementing the indices, because it'll just be like a blank space between actual tiles. So say like this bit here, you'd have like the y incremented like on this line, but then it'd hit that again. So it'd say, all right, we found tiles, so keep populating them. And this basically makes sure that it's in the right place in the array. And the array will have some null elements just to represent the blank spaces. But yeah, that's why. So yeah. Then we do a check to see if the grid bounds are above what the current grid X is, and if they are, we set them. And if I didn't say it before, the bounds are just the final size of the nodes in world. So next, so if we did find a floor tile, so just use this bool called found obstacle, which basically just marks out whether we found an obstacle or not. Then we go through each of the obstacle layers. We try and get a tile from the position that we used to get the floor tile. And if the tile is null, we're good, so we can just leave found obstacle false. Otherwise, we set found obstacle to true. The reason we don't set found obstacle to false here is just that. Sorry. Pardon me. Yeah, so if we found it on one obstacle, found an obstacle on one layer, and then on the next layer there wasn't one, we wouldn't want to reset it to false because there'd still be an obstacle there. So yeah, that's why. Yeah. So if we didn't find an obstacle, we create a node. So we instantiate the pathfinding prefab at x plus 0.5 and y plus 0.5. That is because the nodes, well, the actual position will be at the bottom left corner. So we basically just add 0.5 and 0.5 to get us in the center, which brings us about there for each tile. Just to make it all neater. It doesn't really matter that much, but I find it nicer. Next, we get the path node script off the actual game object we just created, which basically is just basic A star. Can I zoom in? Zoom in? Nope. Give me 1 second. Zoom in. Zoom in. So yeah, this is basically just your standard A star node. And if you have watched that Sebastian Luke tutorial, like I told you to, you'll get what all these things are. Yeah. So basically we set the grid X and grid Y, we set whether it's walkable, we set the world position, and we add it to the unsorted nodes list. We just set the name of the transform, the parent transform. These two aren't necessary for the actual pathfinding, but it makes it a bit neater in the hierarchy and easier to understand where the actual nodes are by name, rather than just having all of them called new game object. And likewise, so if found obstacle is true, we just do the same, except we set walkable to false, and I've forgotten to say that we've got the found tile boolean set to true. So once we've done that, we set it to true, so we've said we've found tile, we can start counting up the indexes, and we know we've hit the array. Okay, and finally, after we've created the tiles, or not, so if we created the tiles, we increment the grid Y, and we perform another check for whether the bounds are lower than the grid X, and if they are, we set the bounds to be the grid values for X and Y respectively. And yeah, and once we get out of the Y loop, so we're still in the X loop, we just finished this one particular iteration of the Y loop. So if we've found a tile, then we increment the grid X and we set grid Y to false, and we say that we've found the tile. We've not said, sorry. We increment grid X, we set grid Y to 0. So we're saying, all right, we've incremented 1, and we're on to the next row or column or whatever you call it. So we set Y to 0, so we're back at the bottom again, and we set found tile to false. And yeah, and once we've done all these searches, we'll have a nice list of unsorted nodes for us to populate into the 2D array, which is what we will do next. And we've just got some debug.logs, so the grid bounds are bound X, and yeah. So next up, we create we just initialize the array. So we created a new 2D array of path nodes of bound X plus 1 and bound Y plus 1. And then for each of the game objects in the unsorted nodes list, we get the path node script of it, and we just set the node in the world to be the grid X, and we set node in world at the coordinates of grid X and grid Y that we stored in the actual path node script here and here. We set that to be equal to the node that the coordinates are stored in, and that basically just gives us an array of nodes in the right position, basically. And then finally, for each of the nodes, in the nodes in world, if P is null. So, like I said, sometimes there will be null elements in the array to represent the potential blank spaces in the world. So, if we reach a null bit in the array, we just continue. Otherwise, we go through each of the game objects in the unsorted nodes. If we do a quick check to see if this particular game object we're checking is equal to the node which we're checking at the time. So we continue because we don't want to set a node to be a neighbor of itself. So if that's not the case, we get the distance between the node we're currently checking and the actual other node. And if its distance is less than 1.5, we make a check to see if the neighbors of the neighbors of P is null, and if it is, we just initialize the list, and then we add the G node to the P node's neighbors, and that gives us a grid of nodes. Okay, so next up we're on to this pathfinding script, which actually controls the getting tiles near to a location and actual getting paths. So first off, I will just hover over the actual code that I won't be explaining because it's just a bog standard. It's just your bog standard A* implementation, so there's no real need for me to do it again. That tutorial I linked in the description by Sebastian League is much better, covers a lot more, and yeah, you should go watch it. But just in case, we'll just hover over it so you can read it. And yeah, so we'll get to the bit I did, which I will be explaining. So yeah, so we will get the nearest. Basically, what the bit I did was the get nearest path node for my particular implementation. And what this does is it will find the nearest walkable node to a position. Yeah. So basically, I'm actually going to kick open ASprite, file new, 100 by 100. I'm just going to give you a quick explanation of how it does. It works. So if I have a grid, okay. Okay, so say if you wanted to work out if the position was, work out someone was here. So for how this finding nearby nodes works, is you would check this node here, its position, you'll see it's less on the x-axis and less on the y-axis than the target node. So we increment on the x-axis, we check again, it's less than the target, so we check again, and so forth. We'll keep going until we reach here, in which case we find that this is actually more than the x, so we know we've gone too far. So we stop incrementing the x index and we start incrementing the y. So we keep going, we keep going, we keep going, and finally we reach here, so we know that this is like too high, so we know we've gone too far, and this gives us our final result of here. Pretty much. And that's the basic principle of how we're going to find pathfinding nodes. So you'll see we have a current position of vector 3.0, which is just we needed a value to start. This basically represents the current point in the world that we're checking. So each time we go through a tile, we'll store its position in here and check it against the position. And these x and y indexes are just to record where our current index value is for the node that we want to return. Okay, so for int x equals 0 to x is less than the 2D array that we created, get length, so this gets the width of the array. So for x is equal 0, x is less than nodes in world.width, or get length 0. So we then get the pathfinding node from that particular, from x and y index, so this basically just starts at 0. but it doesn't really matter because we're only checking, the bottom. So if the P is null, then since we know that our nodes are only spaced 1 unit apart or 1 meter apart, we can just safely add 1 to current position and continue. Otherwise, we can be more accurate and get the current world position of the tile. And then after we've got the position, if the current position.x is less than position.x, then we increment the x index. Otherwise, we break out of a loop saying, all right, we've gone too far. We're on roughly the right x index, so we don't need to count anymore, and we'll start on the y. And then we do an identical thing for the y. So again, we go through int y equals 0 to y is less than pathfinding nodes.me.nodes and world.getLength 1, which gets the height axis or the y axis of the 2D array. We get the current node, so we go for x index and y. So this will go from the bottom to the top on the x index that we found. And again, if p is null, since we know that the nodes are spaced 1 meter apart, then we do current pos.y plus 1. Otherwise, we just set current pos to world position. And again, we check if current pos.y is less than position.y, we increment the y index. Otherwise, we break out a loop because we're done. And the return value is basically just the node in world at x index and y index. And for that, and after this, we have a couple of basic checks. So basically, if the node is null, because again, like we had, we will have null areas in the array because of like potential blank spaces that might exist. So yeah. So we get the nearby. Basically, what we do if the nearby node is null, or the array element we've got is null, we create a new list of nearby nodes. Then we basically get the 4 surrounding nodes. So we get so if the x index is less than the node width, then we add x plus 1. We'll get the x plus 1 node. If x index is more than or equal to 1, we get x minus 1 node. And if the y index is less than the height, then we get y plus 1 node. And if the y is more than or equal to 1, we get y minus 1 node. And don't actually do anything with them, shit. Oh well. Have I just forgotten to it, or has it deleted it? I think it has. So for each, yeah, because it's supposed to. Oh god, it's got rid of it. Okay, let's code on the fly then. Path node nearest equals null. Float dist equals 0. No, 9999. 0f. Alright, so basically what we're doing here is we're going to cycle through all the nearby nodes we found, and if like it's near to where we wanted to actually get the tile, so in this case this position, we will set that to be rep val instead of nodes in world. So for each pathfinding node p in nearby nodes, float d equals vector3 dot distance p dot gameobject dot transform dot position and position. The reason we do vector3 dot distance here rather than in the if statement is that we'll need it again if this node is nearer to the if it's nearer to the position than the current node. So we don't have to call vector speed or distance again. It just saves a bit of processing power. So if d less than dist, nearest equals p, dist equals d, and finally we're just going to add a quick check up here. So if p equal null, continue. There we go. So basically this will check if it basically just checks the next door neighbours of the pathfinding node that was null, and if it can find one, it will set it to be the return value. So it's val equals nearest. Oh god, I've closed off it. And finally, we have a check for if return values, if the node is not walkable, so we want to get the nearest node that is walkable, or we basically do a similar thing, so we get but we don't need to get the actual nodes out of the array because we can just use the neighbours that we assigned in the create pathfinding nodes method. So what we do is we go through create a new list called walkable neighbours. We go through all the neighbours of this unwalkable node, and we add the neighbour p if it's walkable, or we add it to the list if it's walkable, sorry. And then we go through all these walkable neighbours, and if the distance is less than d, then we add it to, then we set it to be retval. And finally, once we've gone through all the walkable neighbours, we will have the closest walkable node to the position that was passed in as an argument, and then we just return it here. And finally, if you want to just quickly test that the pathfinder is working, like I've got on mine, on this path test Zoe, basically we just had this test path follower script with the person movement script on it, and it's basically just a copy of the original character controller we had, but instead of the player input, we got the test path follower. So yeah. So what we do is we got a list of vector freeze for the current path. We got an integer for the path counter that's set to 0. We got a target game object and a person movement script. In awake, we just set the person movement script, and then on updates we check if the target's null. Then if we just get a random node out of the unsorted nodes to go to, and the path is pathfinding.me.getPath from this position to the target's position, and if the at target is false, so this basically just checks if we are within 2 meters of the target node, then we check if at point is false, so which checks if we are near to the current node in the path. So in this case, if we are within 0.25 meters of the path counter, then we return true, otherwise we return false. And so if we're not near the path node, then we just move in the direction of the node and rotate to face it using the person movement scripts. And otherwise, if we are at the node, then we increment the path counter. And finally, if we reach the target, we just set it to null, and we clear the path and set path counter to 0. So on the next loop through, we'll see that the target is null, so we'll get a new target and a new path. And yeah, that's pretty much it for generating pathfinding nodes and stuff from the floors. Yeah, sorry about not actually going over the A star. I mean, I know it seems kind of, I don't know, cheap not to do it, but honestly, it is better, and I couldn't really do a better job than what Sebastian League has done. So I will just leave that tutorial to him. And like I've had, this is my basically little contribution to how to get the nodes rather than using his method of generating the grid, because we are working with 2D tile maps and shit. So yeah, I hope you found it at least somewhat informative. I'm on Patreon as well for the generic plug where I have to pay bills for food and shit. So yeah, I've also got links in the description to all the various shit I've made, like Loud or Quiet on Steam, all the project files on itch.io and stuff like that. And yeah. So cheers for watching, like, comment, subscribe, all that shit, and bye.